I am Anderson, and Anderson Lamek. I'm the Chief Technical Officer at a very, very small startup. Don't think it's just a fancy word. The startup is called Asoft, and my talk today is going to be about Kotlin coroutines for multi-platform. Let me try to make this, sorry. Before we get going, we need to understand the title of the talk, Kotlin coroutines for multi-platform. And before we even try to digest what the whole title means, let's try to address the word multi-platform code. Now, what is multi-platform code? You can quickly be tempted to say that multi-platform code is code that is identified in all platforms. It's code that identifies every single platform. But if you go with that approach, you're mistaken, as currently the correct way of thinking about multi-platform code is code that is not tied to any platform whatsoever. The technical term goes by the word it's platform agnostic. So you just make sure any code that you write isn't tied to a specific platform. Now, to make this easy to understand, we have an example here written totally entirely in JavaScript, and as you can see, we have an example like there's a variable being defined there first, but if you can see how the variable is defined, it's written as document.querySelector. Now, one way you can just tell that this code won't be able to be executed, for example, in a node environment, ergo it ain't multi-platform. But the code below it that just assigns a string to a variable just can tell you how, and it can also show you how this code can work in any platform. Now, since we're talking about JavaScript, the only platform you can run JavaScript is the browser node, and there are no environments. So that is only where this code can run. But just down to the simplistic part of it, it's now you're able to run it to 3 different platforms. So now let's also try to see Kotlin. Kotlin is a language that many of you, I'm sure by now, would have heard of it. But just to recap for those who it's still new to them and they still don't know and they're still not sure whether to pick Kotlin or any other language, here's a very quick overview. Kotlin is a language which has 4 major key points that the team who were behind Kotlin actually made sure they're addressing everything. So Kotlin is concise, it is safe, it is interoperable, and it's tool-friendly. These are big words being thrown around, so you can easily be confused. What do they mean when they say concise? What do they mean when they say safe and interoperable? Now, since this is a 20-minute talk, I will try to explain it slowly, and I will address the facts that are very confusing than other, specifically starting with the concise part. Okay. When we say Kotlin is concise, let's look at an example. Let's say you're trying to define a very easy model object. It's a class of a customer with just simple 3 variables, parameters, properties. He has a name, email, and company. Now, let's look at how the good old Java object, the plain Java object, would need to write this code. You would need to have a whole of these lines of code to express a character, a customer with a name, email, and company. So you have the private properties, you have a constructor, you have the getters and setters, and all of this just becomes messy when you're dealing with real life world applications, because they tend to have many properties, which means your class will have a lot of getters and setters. Yeah, you can argue that you need them, but many frameworks out there, they actually need to use these getters and setters, so it's kind of like the standard. And you can argue saying that, yes, most of these methods are being generated by the tool, let's say the IDE. But also when it comes to code review or maintenance, you have a lot of code that you're looking at that you might easily even overlook to try to update if you're actually implementing some of the getters and the setters. So apart from Java, let's look at even a relative old language, let's say for example, C++. You can see it's almost the same with Java. The only difference is it has no getters and setters, because that's how C++ paradigm follows. But also, as you can see, it's a little bit of code just trying to express an object with name, email, and passwords. So going on to our good old friend, JavaScript. you can see the code gets smaller, concise, and actually it's much more readable. As you can see, it's just a very short of code trying to be expressive. But with Kotlin, you can achieve more, you can get more from this. And this is what the conciseness actually means. It means all the boilerplate stuff you don't have to deal with. Now, looking at the Kotlin code, you just have one single line that spans through and it explains everything. The Kotlin compiler generates the getters and setters for you, and this code can also be used from every other platform which you're trying to interop with. And that is a very huge plus. But also, what do we mean when we say interoperability? When you say interoperability, it means that when you're trying to target Kotlin for a specific platform, say Java or Android, you don't have to go and implement every other thing, or you don't have to go and create a pure Kotlin library. Kotlin already works with what is currently active in that particular platform. For example, if it's the JVM, all the Java libraries that you know and are aware of will be easily usable from Kotlin, and all Kotlin code can be usable from Java. Same goes to JavaScript, Object-C, and C++ and C. In other talks, you might even find Kotlin is being run on iOS, and that is because of its interoperability with Objective-C. And also Kotlin can successfully run on Android because it is very, very interoperable with Java. And up to now, plenty of the Android X libraries have been ported to, plenty of Android X libraries have been in use hand to hand with the Kotlin libraries. Now that we know what Kotlin is, multi-platform code is Kotlin code that can compile and run on different platforms. I've written down one of the major ones. Like, we know that Kotlin now can run on the browser, which means you can write your Kotlin code and compile it down to JavaScript directly, or you can compile it down to WebAssembly and execute it as machine code right from the browser. Also, Kotlin runs on mobile. We know that there's a lot of Kotlin Android devs. Even we had a talk earlier about Kotlin architecture on Android, which is very impressive stuff. Also, Kotlin runs on iOS. Some big companies like TouchLab really active. They're actively developing and using Kotlin in production. Also, we also have Square App, who they developed Cash App. They've also claimed to use Kotlin multi-platform. I can also say Netflix. Netflix also just announced, they released a blog post saying that they too are doing Kotlin multi-platform on Android and iOS. So that's a big plus. Not only on the browser and mobile sides, also in virtual environments, let's say the JVM, the Node runtime, and even the Deno VM, Kotlin can compile code to JavaScript to run in Node and Deno. And also, as we know, Kotlin runs very successfully on the JVM. But also, Kotlin can be compiled down to native code, like bare metal. It can be compiled down to the very specific instructions of the CPU. Actually, there are technical explanations behind that Kotlin compiles this code to something called the intermediate representation, which also is being picked up by the LLVM compiler. And LLVM compiler already targets a lot of platforms down to the machine code. So now that we have already seen what Kotlin and multi-platform is, let's try to dive into know what coroutines are. Now, depending on which platform you're from, it's really hard to initially explain what coroutines are. And since I'm trying to target a larger audience, I will try to do that with the following two definitions. If you're coming from Java or C++ and you've been dancing a lot with threads, trying to perform concurrent executions, you will understand that Kotlin is just like a lightweight thread, and also just saves a lot of memory. Threads typically occupy something like 200 megabytes per execution. So whenever you instantiate a thread, you're taking almost that much size of RAM. But coroutines, they pretty much do almost the same thing that a thread does. Like, they can offload the task and run it in a separate CPU, but they're much lightweight. But also, from someone coming from the JavaScript, TypeScript, or C# community, I can just say coroutines are like async functions. We are going to see what's the difference between async functions and coroutines up front. But for now, I want you to live with the concept that Kotlin coroutines are like async functions. Okay. Now, I've given definitions regarding Java, CPP, JavaScript, TypeScript, and C#, but what does Kotlin say? Um, Actually, if I say Kotlin, I might be misleading you guys. This is my own specific definition. This is my very, very strong opinion on it. It's just coroutine is a code that might suspend mid-execution and resume afterwards. Now, there's a lot of words that have gone down into that definition. The keyword suspend, the keyword execution, and resume are very important in the coroutines land. But since this isn't a talk on how coroutines run, I'll leave that for the next time. But just so you know, any code that you write that at some point in time it needs to wait to get a result. For example, you've executed a task, launched it off to another thread. You are going to you might need to check how you could easily implement that with coroutines. Now, let's see how we can implement this with a toy problem. For some reasons, I cannot instantiate a slideshow, but bear with me. This could have been more easier if we could have tried to make it a slideshow, but let's go. So let's try to create a problem so for you guys to understand what problems are coroutines trying to solve. For example, we are trying to create a service whereby someone can just hop into our application and select from multiple restaurants, and also after selecting from multiple restaurants, they can also select a specific menu from that particular restaurant, and then when they get the menu, they select the food and they make an order and their order arrives. So we're going to define a function called fetch restaurants, and just as a normal function, it takes a callback which returns a list of restaurants. And I need you to notice the question mark. The question mark signifies that this restaurant might be now. So maybe the internet connection was down. Somehow we failed to communicate with the restaurants, or there is no connection. So we might want to bring an error and let's say return null for that. So now, but when you fetch restaurants, the implementation is hidden. It's not actually the scope of the scope, but we just know we have a function that can fetch restaurants and takes a callback, which also will give you the list of restaurants when the fetch is completed. Also going to define another function called fetch menu, where you are going to request a particular menu from a specific restaurant, and you're going to provide it a callback, what you will do when you get that menu. Also similar, we're going to place an order. This will take various arguments of foods and also a callback on an order ticket if your order of that specific food you're ordering has been placed or not. If it's not, you're going to return null value. Now, trying to see this provide service method right here, you will understand that you're going. Well, first of all, we're going to call fetch restaurants, and we know it's a callback that takes restaurants, and the user will pick one restaurant from the list of the restaurants that were returned by the saver. And for now, for the purpose of this problem, we just pick the random restaurant and we return no restaurants found in case anyway. So once we have that random restaurant, we can go to fetch menu and we pass the restaurant that we've obtained from the service above, and also we pass a callback because we expect this to get menu list of foods from this menu. And when we do so, we get a menu, and again we're just going to pick a random menu and place an order for that menu. If the ticket is null, then is not null, then the order is successful. If the ticket is null, then oopsies. But you can see the problem that we're trying to address. Now, this code is very readable, yes, understandable, it works, but it's not concise, it's not readable, it's very hard to follow through what's going on, and this is a toy problem. In real life situations, you're going to have to do error handling, you're going to have to throw some try-catch blocks all over the place. So this is already messy, and if you look down here, these steppy closing curly brackets actually have a term there called a callback hell, and when you try to Google that term, of coroutines was introduction of futures or promises and any other paradigm or naming that came up with. It's just that your wrap, there is the parameter that you expect to be returned in some sort of a variable. For here, I just decided to use promise because it's kind of familiar with those JavaScript developers. But also, so our fetch restaurant function now, instead of taking a callback, we see now it doesn't take a callback, but it does return a promise for list of restaurants. So is our function fetch menu, no callback, but returns a promise. And also our function place order, no foods. I mean, it takes an argument of foods, but also it returns a promise of the order. So when our user comes into our application and we need to provide the service, we first call fetch restaurant. And after calling fetch restaurant, then these are called operators in promises. And the then operator just says, when this execution completes, execute this code. Now we're expecting a restaurant from it. And again, we pick a random restaurant and we call fetch menu from it. Now what we do, fetch menu, remember fetch menu also returns a promise. So we can join again at then if we are returning a promise. So we're joining then. Then after fetching the menu, you're going to get a menu. Then you're going to pick a random food as usual. And you're also going to place order. When you're placing an order, we're expecting to get a ticket. So when the place order promise returns, we just call then. We go down to the ticket. If the ticket is null, then we fail to place order. But down here, we can say like, yay, we have our order, because Kotlin has this called null checks, and they're smart casted. Until down here, if your ticket is not null, then it won't throw this error. And down here, moving forward, the compiler will treat your ticket variable as a non-null variable, which is so good in practice. You have no idea. There is no way I can even convince you how just by words. You're just gonna have to go and try it out for yourself. But again, all of these operators do have a catch method. So in case any of the above promises fail, we're going to catch and handle it. Now, while this is much better improvement from the previous code, we have already the callback hell. Our code is much more expressive, but we can do more with Kotlin. This is why the power of Kotlin is where the power of Kotlin shines. Now let's see how we're going to approach this from the Kotlin side by using Kotlin coroutines. By using Kotlin coroutines, our function fetch restaurants has, you add a modifier, it's just called suspend. It's a suspend function, and I need you to notice that it returns a list of restaurants. So trying to read this code, you're saying I'm trying to write a function that will suspend, but it's fetching, and I'm expecting a list of restaurants. When you say the suspend, the compiler knows how to treat this function, and it just knows that this is a function that at some point in time, it's going to be wait for a result or wait for anything for it to be returned. So just by doing that, your code is very expressive. Now our functions fetch restaurants, fetch menu, again takes a restaurant and returns list of food. It's also suspended. Same goes to place order. So when our user comes into our application, we're going to call fetch restaurants, and for the purpose of this demo, we're going to call random and get a random restaurant from it. Now we have a random restaurant. Also, we're just going to get food by passing the restaurant into the fetch menu, and we have the food. We're also going to have ticket plus order, and down here we do have a valid ticket. Now this is asynchronous code, but it appears concurrently. This is asynchronous code, but it appears sequential. That is one of the powers of Kotlin coroutines. The code looks and is executable and reads as if you are just writing imperative code, and that is one of the great power of Kotlin coroutines. You'll never get lost in trying to read codes that suspend or have to wait or anything like that. Now, that is the power of Kotlin coroutines, but remember this talk is about Kotlin coroutines multi-platform. So whenever you have written such a code, and with coroutines, this code can be platform agnostics. We haven't used any platform dependent. There is no Android system here or browser. There is also no Windows system from the Windows. there is no any desktop dependency on this code. So it is very platform agnostic. And what does that mean? It means it can be executed on all platforms. Now, all I want to say about this talk is Kotlin coroutines are great. They help reduce the strain in code. They also make us be able to skip all of those heavy bug fixes just because we didn't handle some networking problems correctly. So my word to you guys is write Kotlin coroutines once and run them everywhere. Thank you. Yo, and the wireless that we're using here is called Kotlin, and the password is Kotlin everywhere. So thanks everyone. It was so great to have you guys. So yeah. So maybe if someone has any questions regarding this talk, you're only welcome. And sure. Hi Georgie.
Hello.
Jenny.
Thank you so much for your talk.
Thank you.
We have one question.
Okay.
How heavy is Kotlin on the server compared to other languages such as Node.js?
Kotlin is very great on the server side, and we have multiple frameworks, but the one that I would strongly recommend is called Ktor, because Ktor is like the Express of Node.js, but written in Kotlin. It's very heavy in server-sided, but even those who have been using Java, for example, the ones who have been using Spring Boot, Kotlin also runs properly in the server as Spring Boot. So you have vast options. There are a lot of libraries out there. There is HTTP4K, there is Vertex written in Kotlin, Vaadin. So you won't be locked. It's just another JVM language. And let me just say, Kotlin is the JavaScript way of writing Java. That's all I can say. So it's very powerful, and it's also super, super strong when it comes to the server side. I believe I've answered your question, boss.
Yeah, I suppose you did. So
yeah.
We also have another question. What is your Twitter handle?
My Twitter handle is Andy Lamas. So it's just Andy and LMAX. LAMAX. Andy Lamas.
Can you type this on the chat?
Okay, really quick chat. There you go. Andy Lamax. I forgot the underscore. There you go. It's on the chat. So hope you follow me. I'll be famous.
All right. Thank you, Andy. Thank you so much for being here with us today. We hope to see you next time.
Bye.